So these functions are special. You can also create your own function with your own name, but these functions are special and which are defined in these library, which I discussed earlier. So what is the role of void start? You see in the comment lines, you have something written here. Start is called before the first frame update. Okay, so what this does is, whenever I start a game, so let me go to Unity, and when I hit play, you observe that when my this play button turns blue, this is the point at which my game starts running. So that is the point where my game starts. So that is the point where this function will execute. That is my void start. Whatever code I write in between these curly braces, those lines will be executed at the start of the game, and those lines will be executed only once. Like okay, let's test it. Suppose I want to print something. Let's say printing into the console. I discussed about the console yesterday. This is my console. If you move to this window, and I guess you already have this. If you don't, just go to Window, General, and you will get the console here. So yeah, under console, I want to print some message that my game runs. So let's write something. So debug.log is the same as printf in C. It prints something. So debug.log writes a debug message to your console. So I want to write my start function executed. Alright, and since I'm using a string, I want to print this, so I'll be writing it under double quotes, semicolon to indicate termination of the line. So what this does is, what I expect is, at the start of the game, the console will print this statement. So let's see if my guess is true. Yeah, also please make sure that after writing something, you press Ctrl S on the keyboard to save your script. Only after saving will the changes be reflected to Unity. Let's see if my code works or not. I'll hit play. Okay, did any message appear in my console? I wanted my start function executed to be executed in this console, but nothing is being shown. So what is the reason? The reason is because we have created a script, and we have just added into our file directory, which is under assets and scripts. I just created a script, but I haven't added the functionality into my game object. Like this object cube, this sphere, this plane, these things inside my game scene doesn't know that this script exists. We haven't told them that yeah, there is a movement script, and they have to execute something. So what I'll do is, I'll just take this and I drag it into the cube. Anything, you can drag it into the cube or the plane, the sphere, any game object you want. So when you highlight cube, you will find that in the inspector panel, you will find the other components. There is an additional component now, which is the movement script. So yeah, your script has now become a component to your game object. So yeah, you can write your own script, you can create your own functionalities and make your own component. So all these things which you see, the rigid body, the box collided, these are basically what you called predefined scripts, which are manifested as components for your game object. Okay, so since now we have attached the script to my cube, let's run my program again. You see, as at the point when this play button turned blue, my start function executed. So what is this? What is the functionality of update? Similarly, I want to print something. Let me see what happens in update. So I'll print debug.log update it's executed. Fine. Control S to save. Now let's go back to Unity and again test my game. Just take a note of the console here. You see something, update gets executed, and it's so many of them, and it's still getting executed. You note this number here, 700, then 800, and now 900. So these many times your update gets executed has been printed. So what does this mean? What is this functionality represent? So your game works in terms of FPS. Like it executes and carries forward other executions every frame. Like one frame it executed something, then the other frame it executed. So what this update does is it executes the line of these set of lines every frame. So update gets executed. Suppose my system runs at say 40 FPS. So this statement update gets executed will be printed for 40 times. So that is what this update function means. So you can call it a for loop. Let's say you can call it a kind of a loop. Okay, so I'll be running an FPS system using my script. So let's clean up my scene. So my scene is clean again. And what I'll do is I'll create a ground first. I'll scale up the ground. Let's say 10 in the X and 10 in the Z. So this will be my ground. Change the name of this game object. Afterwards, what you do is I want to add a player. So under 3D objects, I will select capsule. Let's see how does it look. So my capsule has this kind of a shape. It's actually a capsule. Let's rename it to player. So yeah, and it's mixing with my ground. So I want to change its color. We had already created a material for my player. So I'll just drag it and I got my red color. Okay. And yeah, when you add your player to the scene, you will find that it was just below the surface like this. So just use your Y and drag it up so that it lands on the it's not perfectly landing, but try and bring it almost as close to the ground as possible. Now yeah, let's create a movement. So what I'll do is this is my movement script, and I'll make the player move. So for movement, I will need the help of some component. So what I'll do is I'll add a component to my player. So I'll go to add component and tap in character controller. You see the character controller popping up. I want to add a component named character controller to control my character, to control its movement. So I'll go to add component. In the search bar, write character controller. I got the character controller. Just select it and you will add your component. We'll be taking the help of this character controller to make our character move in the using the WASD key. So I'll go to my script. Let's write our code inside update. So we won't be needing the start for this. So I'll delete it. And yeah, as I mentioned, I'll be using this character controller to move my character. So I'll be referencing it. So what I'll write is outside the update, public character controller. Make sure you use the same spelling and the same uppercase and lowercase letter. You follow this order exactly. Public character controller. Let's name something character. So it's like this is your access variable, this is your data type, and this is your variable. So it's the same structure. And character controller is the same thing as this. So I'm trying to reference this data type. I want to create an instance named character of type character controller so that I am able to reference this. So I'll declare this, and yeah, let's press Ctrl S. So how do I make sure that it's referenced? Like I can have another character controller in my project, and if I write only one, then which one will it refer to? So, and since you have declared it public means that your character variable will be visible to you in the inspector. When you go to the inspector, you will find, okay, important thing, you will have to add the script to your player. So drag your script to the player. You find that the component movement script is being added now inside the inspector, and your character, which is the variable you defined yourself, is now having an empty space. Now you can reference this character controller to this variable. So what I'll do is I'll drag this and place it in this empty space. Since there is motion, I want some speed, right? Like I want, let's say I want to make the player move at some speed. So I'll have to specify the speed. So that also we'll have to mention. So I'll write public so that it appears in the inspector and we can directly edit it in the inspector. So public float, again you are familiar with this float, public float and speed. Let's say I want it to have 10 speed. Since you're using float, I will write 10f. Okay, so this will be my speed, Control S, and my speed will be updated here. Fine. Inside the update, what I'll do is I'll write float x equal to input dot get axis. Inside that, horizontal. So what this does is input.get axis. You can and it's trying to access the horizontal. Again, similar thing will happen for float z. Why not y? Because remember, y is perpendicular to the surface, and I want to move it like this along the x sideways and forward backward along the z. So I'll write float z equal to input dot get axis. Inside that, I'll write vertical. Since my player is moving, so I'll need some velocity, right? I need to know the direction. Where is it moving? So I'll declare a variable named velocity. So vector 3 vel. Okay. So vector 3. What is vector 3? Vector 3 is nothing but a data type which stores, which has a type, say, of 3 coordinates. It stores data in this fashion: A, B, and C. So this A represents X coordinate, B represents Y, and C represents Z. So my vel variable has 3 types, stores 3 types of data: X, Y, and Z. And remember, vel is a vector. So like in vector addition, we'll do the same thing here. Vel equals to transform dot right dot not dot into X plus transform dot forward times Z. Okay. So what does this mean? Transform means that you are trying to call this transform, right? Like if you have written the script movement and you have attached this movement script to your player, then writing transform will imply that you are trying to refer to this component transform of the player. Transform returns a vector. That's why we write transform. And this will result in a vector which points to the right direction, towards the positive x-axis. So similarly, when you suppose you're trying to press W and D buttons together, so it will move diagonally, right? That is, it will have a component along the Y and x-axis, along the Z and x-axis. So this will have +1 along the x, and this will have a +1. Dono ka addition will give me the net vector. So this is simple vector addition. This is well, and okay. So this is my velocity. Now, yeah, I want to add this velocity to my player. So I had referred to the character control previously, right? So I'll be using this to move my player. So character dot move. Character is the same thing which you named here. See, it's highlighting, and move is the special keyword which is inside the character controller. So move, and inside that you will write where to move. So I want to move it in the well direction, but is well enough? Like I want to specify at what speed it's going. So I'll multiply it with speed. I'll write another thing, which is time dot delta time. So this time dot delta time is what makes it possible for different systems to function in the same manner. Just like I mentioned previously, that different systems run on different FPS. So this time dot delta time tackles that issue. Suppose your update function executed now, your time dot delta time started recording the time occurred. Then let's say after about 0.001 seconds, your next update function executed. So this time dot delta time stores the value 0.001. So it stores the time taken for consecutive update function executions. So what happens is, for a high FPS system, your time dot delta time will be less, and for low FPS, your time dot delta time will be more. So low FPS will execute this update function lower number of times, multiplied with a higher number will normalize it. And for a high FPS system with a low value of time dot delta time, it will normalize it accordingly. And that's why we multiply this time dot delta time. Okay, so yeah, I think our code is ready now. Let's test it. Control S to save. And okay, let's play. So take a look at my scene window. I'm pressing my W button now. Let's lift it up a bit. I guess it's getting obstructed. Okay, so when I'm pressing W now, it will move forward. I'm pressing S now, it is moving backward. I'm pressing D, it is moving right. I'm pressing A, it is moving left. Now I got my motion. I can change the speed. So accordingly you adjust your speed. Okay, I'll go to the mouse look part. How do you look around using your mouse? So for that, what I'll do, as I mentioned in my previous session, that my camera, whatever my camera records, that is what is being shown to the player when he plays the game. So I want to make the camera as the eyes for my player. So let's do that. I'll go to player. I'll go here and go to this settings icon here. Click it and go to copy component. And inside main camera, you can go ahead, paste component values. You see what I did here is I replicated the transform. I copied the transform values from player to the main camera. My camera lies in the same orientation and position as my player. Okay, so eyes are a bit towards the head, right? So let's lift it up. Okay, this is fine. Let's start my game. But my camera is not moving. It should move with the player, right? So that it works as an eye. So what I'll do for that is I'll drag this main camera inside the player. Everyone did till here. I'll repeat again. I selected my camera. I dragged it inside my player. So you see a hierarchy kind of a thing has appeared. And this means that my main camera is now a child of my player. If I play now, my camera follows its parent. Okay, so it's following correctly. Now let's write a script so that we can look around using a mouse, like in an FPS game. So we'll add a new script again. Create C# script, mouse look, double okay. Drag this inside the camera because we want to make changes to the camera when we move around the mouse. So drag it inside the camera. Make sure that your camera has the mouse look. Okay, then let's start editing the script. So first business is what we'll do. is first we'll try to get a reference, like we'll try to get a reference for the player. Okay, let's keep that, we'll discuss that later. First, let's try and get the information about my mouse. Like I want my camera to look right when I move the mouse towards the right. Like in the normal mouse FPS looking kind of a scenario that is what I want. So for X motion, I'll store the information when my mouse moves horizontally. So what I'll do is inside the update, I'll write float mouse X equal to input again dot get axis again, and this time inside this I'll write mouse X. Okay, so your mouse X information is stored here. Similarly, I want the mouse Y, that is when my mouse moves vertically, I want to store that information in the mouse Y variable. Mouse Y input dot get axis, inside that mouse Y. Okay, so for moving our mouse, just like for our player movement, we needed some speed, right? So similarly, for our mouse movement, we need something called mouse sensitivity. So how sensitive is your mouse? For a small motion, you get a large rotation of your camera. So that adjusts your camera, your sensitivity. So I will define it public so that I can edit it inside the inspector. Float sensitivity. Okay. Let's set it to some value, say 20f. Fine. What I'll do is I'll get the information from the mouse X and I'll multiply it with the magnitude of the speed sensitivity. Similarly, I'll do this here. I got the information of the motion direction and then I multiplied it with the magnitude. Again, I'll be, since update is there, so I'll have to manage for different systems, so I'll be using time.delta time here as well. Time.delta time. So my mouse X and mouse Y stores the information for X rotation and Y rotation. So what I'm trying to do is when I want to look right and left, so I want my player to rotate about the Y like this, and when I move the player, I will move the camera along with it. So it's like if you turn to the right, it's like turning your body to the right. You are looking to the right direction and you are turning your body as well. So that's why for this we have to rotate the player body. So yeah, let's get a reference to the player body. So public transform. Again, this transform is referring to the transform inside the player. Transform player board. Okay, so let's refer to it. Similarly, I'll drag my transform. The main my script is inside the main camera, so I'll drag my player inside my player board. So automatically my player transform is being referenced. So what I want is I want to rotate my player body when I move my mouse along the X direction. So for that I will do player. I have referenced it inside the player board, right? So player board, which is of type transform. So player board dot rotate, which means it will rotate the transform, and it will rotate about what? It will rotate about vector 3 dot up. Vector 3 dot up means this is just a special name for y-axis. So vector 3 dot up, and it wants to rotate it by what? Like I got the direction, I want the magnitude now. So magnitude is mouse X. So let's test my XY motion. So since my scene is empty, I will add some elements to it so that we can easily make out where my player is looking at. So I'll just add this here. Okay, so let's play the game. Take a note of my mouse position. I am moving towards the right and my player is looking in the right direction. I am moving it left and my player is looking at the left. I am moving it up but nothing is happening. I am moving it down, nothing is happening. If I move it right, and I press W, it will move forward. Okay. So let me reduce the speed. Okay, so we achieved mouse X rotation. Now let's tackle the mouse Y. So what I'll do is I want for the mouse Y, if I do the same thing, if I rotate the player around the X axis, for it to look up and down, it has to rotate about the X axis. I think it's obvious. So yeah, if I rotate the player body, let's see what happens. If I rotate it about the X, you see, my camera is looking down, but my player body is also tilted. So I don't want that. I want just my camera to look down. I'll just be rotating my camera. For that, I'll be defining a variable first, so which is float local rot, which means I want the local rotation of the camera, not the whole body. So I will update local rot minus equal to mouse Y. Minus is set because of the orientation. Like when you rotate, when you are looking down, you want to increase your angle about the y-axis. So that's why there is an inversion here, and you write local rot minus equal to mouse y. That is, you are decrementing your local rot by mouse y magnitude. But can I do it infinitely? Like if I continue pulling my mouse down, it will just make a full rotation of 360 degrees, which means my camera is flipping. So I don't want that. You cannot bend your neck to look down and make a 360 degree turn vertically. So there is some limit. So we'll add that limit now. We'll write local rot equals to mathf.clamp. These are again predefined special functions in Unity, and I want to clamp my local rotation between minus 90f and 90f. So I'm clamping this value between minus 90 degrees and plus 90 degrees. That is, it can either vertically look up or vertically look down. Now, to add my rotation to my camera, for that I will be doing transform. Transform again refers to the main camera transform. Dot local rotation. Since we are rotating the camera locally, it's not in the global axis now. Equal to quaternion dot Euler. By what magnitude? Quaternion dot Euler means it specifies the angle at which you want your camera to be oriented. So I want it to be rotated around the x, so I will write it in the x axis, local rot, and the rest axis will be 0. So local rotation along the x, y is 0 and z is 0. So my rotation about y and z axis is 0. Okay, so this I have done. Let's test it. I'm looking down and I'm continuously pulling it down, but I can't. This is my limit. Again, I'm going up and this is my limit. Let's increase the sensitivity a bit. Instead of 20, let's make it 40. So you can adjust it based on your convenience. Yeah, so this is how you can easily look around in an FPS game. Alright, and but my mouse is coming up on the screen, so that is not what we see in an FPS game, right? So what we'll write is, inside the start we'll mention a command which is cursor dot lock state cursor lock mode dot locked. So what this does is it locks my cursor onto the game scene, and just look at the result, what this is. So when I play, my mouse is no longer visible and it looks like a FPS game. So I'm able to move where I can look around, and you can try and experiment.